Hey, Topping Life's Math and History, and we're gonna be talking about the introduction to slopes. So in this video, we're going to learn about a unique equation that we will be using in order to graph slopes on a graph, and we're going to explain why we need it in the real world. When you think of slopes, this is what you might think of. That is exactly what a slope is, a simple line on a graph. So, to calculate a slope on a graph, there is a formula that we're going to use. The slope is going to be rise, that means you go up, divide that by run, which is going to make you go run. Or y divided by x. The reason why we use the letters y and x as the formula for slope is because they represent the axis on a graph. So here is an empty graph. And with y and x, the line that's vertical, reaching from the bottom all the way to the top, is going to become your y-axis. And the line going from left to right, which is a horizontal line, is becoming your x-axis. That's why in the formula for slope, we use y divided by x. And the reason why is a slope moves like rise divided by run. Here is the equation that we're going to be seeing a lot when we calculate the slope of something. The equation is y equals mx plus b, or we should also call it y-intercept, because when you put numbers in for x, you'll get an answer as y. And when you do that for multiple numbers, you'll be able to create a graph and put a bunch of plots and dots on the line, which means that when you connect them all, that tells you it's a slope. So, with y equals mx plus b, your x is going to be called your input. When you input any number in for x, it will make an equation, and that will result in your output, or y. This is what you get as a result of your equation. The letter m in the equation means the slope. The letter m actually means the slope. So when you have a number inserted in for m, it will become a coefficient of x. And our last but not least, we have b. That b is going to become our starting position. This is where the slope will start and it will go up or down away from that starting position. The mathematical way we say it is called a y-intercept. The reason why we call it a y-intercept is because the starting position is going to be somewhere along the y-axis. It could be here, 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 or here, or anywhere on the y-axis. So, let's see an example where we would have y equals mx plus b have a bunch of numbers. So, on the bottom of that, looks like we have an equation of y equals 3x plus 7. So, what we're going to do is we're going to be using a ratio table and seeing what happens if we put 3 plots on a graph. And will it become a slope? Let's find out. So here's the equation, and here is a ratio table. Type in the comments below what you think you should insert in for x, because this is a time to get creative. So what happens if we insert the number 2 in for x. What will we get for our y? This is where the math comes in. So if we rewrite the problem as y equals 3, multiply that by 2 because we have 2 inserted in for x plus 7, what will we get? 3 multiplied by 2 is 6. And if we add that by 7, we're going to get an answer as y equals 13. Just like what we said when we were introducing the equation, your y is going to be your output. So what we got when we inserted 2 in for x as 13 as our y, if this ever happens. Let's insert another one. What happens if we insert 1 in for x? What happens? So we have y equals 3, multiply that by 1 because 1 was inserted in for x, and we add that by 7, which is our y-intercept. 3 multiply that by 1 is going to be 3. And if we add that by 7, 3 plus 7 is 10. So y for this example is 10 if we have the 1 inserted in for this x inside this formula. So we get 10 for that scenario. But let's up it a bit. Let's put the number 5 in for x. What will we get? So we have y equals 3 multiplied by 5 that was inserted in for x, and we add that by 7. 3 multiplied by 5 is 15 plus 7. 15 plus 7 is going to be 22. So y is going to be 22, 2. So that's what we're going to get for a y if we insert 5 into the formula. So our last step of finding this slope on a graph is actually graphing on the graph. So let's put these on to the graph. But wait, how do we even graph? So we have an empty graph right here with y and x-axes. What we made on the table is going to become graphs. So what you inserted in for your x is going to be on the x-axis. And what you got as a result is going to be your y-axis. So when you see points on a graph, you will usually see the x first with a comma sign with y, but with parentheses between the two. Or for an example, 2, 13. This will become a point on a graph. So let's graph that. Remember, the x-axis comes before the y-axis. And since we got 2 to 13, we count 1, 2. That is going to be our x. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this would be our point right here. 2, 13. Let's put the other points on the graph as well. Great! We have now put all the points on a graph. But now let's insert our formula. Y equals 3x plus 7. And we'll see a line covering the dots on the graph. And we'll see if these points match this formula above. That means the lines will be touching the dots. Let's see what happens. Yes, that is definitely a slope, and these points definitely make it on the formula shown above. So we have successfully made a slope. The reason why we use slopes in real life is because it measures how steepness a slope is, and it also measures in what direction the slope is. Usually, when slopes are going in a direction, they go from left to right. So they go this way. They try to face the right position. There are some slopes that are in the other option, which means that they still go to the right, but they may start up there, and they might go all the way down right here. No matter what kind of slope it is, it will always be pointing right. The slope that we have been using in the last few minutes of this video, that tells us something right off the bat. That is saying that y is going to equal go up by 3 and run one time. Because if you have x, that is interpreted as 1x. If you have x plus x, that is going to be interpreted as 2x. So when you're measuring the slope, you're doing rise divided by run. So it's saying rise up 3, run by 1. Rise up 3, 1 by 1. Here's an example where you would find the slope in real life at your house. You can experiment with slopes at your house, because when you're climbing upstairs, you're going to have to rise up your foot and make your foot slide forward and run. Rise, run. Rise, run. And let's get to the top of the stairs. I hope this video has helped you understand the introductions to slopes. Thank you for watching Top of Your Life's Math Industry. Like and subscribe.